Welcome back. In this video, we're going to bring the ideas of pyramids, prisms, and Platonic solids together and compare these shapes. By now, you have seen that these solids are not just random shapes. They belong to families with definitions and patterns. That is one of the most powerful ideas in geometry. Let's start with a quick review. A prism has two congruent parallel bases, side faces that connect the bases, and if that base is an n-gon, there are n plus 2 faces, 3 n edges, and 2 n vertices. A pyramid has one polygonal base, triangular side faces, and the side faces must meet at a single apex. If the base is an n-gon, there will be n plus 1 faces, 2 n edges, and n plus 1 vertices. A Platonic solid is a solid whose faces are all the same regular polygon, and there are exactly 5: a tetrahedron or a triangular pyramid, a cube, an octahedron, a dodecahedron, and an icosahedron. Sometimes a shape can belong to more than one idea we've discussed. For example, a cube is both a Platonic solid as well as a prism. In addition, the tetrahedron, this one is a Platonic solid and also a pyramid. This is an important reminder that mathematical categories can and often do overlap. Now, let's revisit some of the reasoning questions from earlier, because these are the kinds of problems that help students notice structure. Let's suppose a prism has 20 vertices. For a prism, we should have 2 n vertices. So this tells us that our n is 10. The base has 10 sides. It's a decagonal prism. Our faces for a prism is n plus 2, and 10 plus 2 is 12. And our edges for a prism is 3n, and 3 times 10 is 30. Let's suppose we have a pyramid that has 31 vertices. For a pyramid with our n bases, our vertices is going to be equal to n plus 1. This tells us that n is going to be equal to 30, so our base will be a 30-gon. In addition, the number of faces for a pyramid is n plus 1, and 30 plus 1 is 31. The number of edges for a pyramid is 2n, and 2 times 30 is 60. These examples show that once you know one measurement, you can often determine the others. That's a valuable algebraic and geometric connection. As a future elementary teacher, there are a few teaching ideas that are especially useful here. First, encourage students to use precise vocabulary, such as face, edge, vertex, base, prism, pyramid. Second, use physical models whenever possible. When students can hold a solid, trace an edge, point to a face, and count vertices, the geometry becomes much more meaningful. Third, ask comparison questions. How is a prism different from a pyramid? What stays the same in every prism? What changes when the base polygon changes? What solids have triangular faces? Which solids have square faces? These questions help students describe shapes based on properties rather than appearance alone. One final note. Learning geometry is not about being fast. It's about being observant, careful, and willing to look for patterns. If you are taking your time and making sense of the structure, you are doing exactly the right kind of mathematical thinking. You've now explored prisms, pyramids, and Platonic solids. You've counted faces, edges, and vertices, built definitions, and found patterns. That is strong and meaningful geometry work. Great job, and keep going. Each time you look for structure in mathematics, you are strengthening the habits that help both you and your future students succeed.